What's up, guys? It's Nick from Hi-Fi for All. It's Friday, November 22nd. I just wanted to do a video series for you guys to just bring you along on the journey on what it's like to build the HFA Dahlia headphone. I think it'd be cool to just, include you guys on some of the stuff that I'm doing, working on as I'm building these headphones for you guys. I just wanted to maybe show you some interesting things about how it's put together, how it's built, and maybe even offer some thoughts on some of the design decisions that I made along the way. There was a lot of problems that I worked out through the prototyping and design phase, and I think it'd be cool to just chat about that and just include you guys on this whole process. I mean, I'm in the garage building these headphones, and I thought that'd be kind of fun for you guys to check out. So all right, let's get started with what we're going to be building today. Okay, so here we are at the bench, and what we're going to be building today is the socket for the HFA Dahlia. So what we're going to do is I'm going to step you through what it takes to build it, and so we're going to go from just the parts here all the way through to what the finished product looks like. And I'm going to take you through that process and talk about how it's built and how it's made. Okay, so first thing that I do usually when I build a socket for the headphone, and we need 2 per headphone, so just times this by 2 per headphone, but we're gonna first pull out about 6 inches or so of this copper, because we need to wire up this socket, and we need 2 pieces, one for the positive and one for the negative. So all right, so I'm just gonna snip off that, and then I'm gonna cut this in half. Okay, so there we have it. So now we have 2 pieces of copper wire. Now this copper wire is actually really excellent. It's a high purity 7N OCC copper that I got that's really low strand. I think there's only like 7 strands in here. And so what that means, it's not gonna be super flexible like a headphone cable, but it doesn't really need to be. It just needs to have really good conductivity. And so basically between the socket and the driver, you're gonna get a really high quality OCC copper. And so if you have a really nice headphone cable, or you upgrade to our own OCC copper headphone cable, basically what that means is that the entire connection between your amplifier and the driver is gonna be all really good, and we're gonna get good copper all the way through. So that's really important here, and so that's why I chose this type of copper, and specifically the type of conductor. Okay, now the next step is going to be to strip each one of these so that we can get it ready for tinning. And so I'm going to go ahead and strip off just one end of each copper wire. All right, there we go. Now that's stripped. And then the next step is to prepare the socket itself. So we're only going to need 2 poles for this socket. It's a 3.5 millimeter. It's actually designed initially for a PCV, to go into a PCB. It's got these like PCB little contacts, but we're actually going to solder it directly. And we're going to clip off one of the contacts because we only need 2, one for the positive and one for the negative connection on the driver. So we're going to clip this front one, and there you have it. The back one is the positive connection. That's the tip of the connector when you plug it in, and then the middle one is for the negative. Okay. Now that we have that ready, we're going to go ahead and proceed to solder it. Okay, so I'm going to see if I can get this in the shot so that you can see it. Okay, I'm going to put the socket this way. Okay. I don't know if we can see that. Let's see if I can zoom out a little bit. Okay. All right. That looks okay. Okay, so I have my solder over here, and I'm going to be using a pretty decent quality solder. And I'm sorry if there's noise in the background. That noise is actually water. So we have like a flash flood warning here in San Francisco. It's pouring raining out. It's torrential downpour, and then that noise in the background is actually my gutter near the garage. So I apologize if it's annoying and loud, but hopefully it's not too bad. Going back to the solder, so this is it's a Kester solder with a pretty high silver content. So this is, I think, a 3% or 3.5% silver solder. And silver obviously is an excellent conductor. It's even better than copper, and that's why you want a little bit of solder in your, or silver in your solder. And so yeah, we're gonna use really good solder here. And we're gonna prepare actually we're gonna get the wires tinned up, and then we're gonna get the socket prepared. Okay, so here's our 2 wires. First thing we're gonna do is just tin these. Okay, there's 1, and there's 2. Looks pretty good. And then the next step is going to be to solder the contacts on the socket. So this is the negative. Get that prepared. We want to put a nice little blob there to make sure that we have a really strong connection between the wire and the socket. Okay, now, so we have the socket prepared, we have the wires tinned, and now we're going to start to put the wires here. I like to put a nice little blob, but not too crazy. I'm gonna do the first one, then I'm gonna do the second one, just the positive. Kind of tricky doing this behind a camera. All right, that looks pretty good. I'm just gonna kind of smooth that out a little bit. There we go. Okay, so that looks pretty good. We're gonna give it the old pull test, tug test, to make sure that it's really strong and can hold up to abuse, which it's never gonna be pulled on, but it's always good just to test it this way. Make sure the solder contacts are very solid, and it looks like they are, so we're good to go. Passes the tug test. Okay, so now we have our socket soldered up, and the next step is to insert it into our enclosure. And so this enclosure is made out of a really strong nylon. It's a glass-infused nylon that's been created using multi-jet fusion technologies. It's a mouthful, but what that means is that basically you have a very, very light and very strong part here that will hold up to many years of abuse. It's also super accurate. Yeah, it's super accurate. It's important when you work with other things that have a fixed size, because accuracy when it comes to manufacturing is really important. These things have to fit together perfectly. So why don't we go ahead and insert the wired socket into the enclosure here, and I'm just gonna work it through. It's very, very, very tight. There's no movement left to right at all. And I kind of get started with my hand initially, and then I use a pair of pliers to continue. Actually, I'm gonna use a pair of tweezers first, just to get it started. Let's see here. All right, so we're just gonna work it in a little bit. There's not a lot of room in there. Okay. And now I'm gonna use a pair of heavier pliers to just really finish this off. Kind of just squeeze it forward a little bit. The other thing I'm gonna do is I'm gonna fold down this little post here so that it fits underneath this little bridge. So you can kind of see here, I'm gonna fold that down so that it clears the little bridge there, and then squeeze it forward. All right, that looks pretty good. So you know the socket is far enough forward when the end of it is pretty much flush with the enclosure. There's a little bit of a chamfer at the end to make inserting your headphone cable easy, but for the most part, it's pretty even, pretty flush there. Yeah, maybe a little more. All right, that looks good. Next step, once we have the socket fully seated and we have the cable kind of bent down the bridge, we're gonna insert this little locking Lego. It's like a little Lego piece that's made out of resin that I made that basically creates it fills the void in the enclosure and makes sure that it's completely locked down. I call it a socket lock. It's got a little chamfer on the bottom so that it makes going in here a little easier, but it's very, very tight fit. I'm gonna start it with my hands, but then I'll eventually need a tool. So I'm just gonna get this started. And then we're gonna push the lock down using a pair of pliers because it really does squeeze in there pretty tight. All right. So now it's fully in there with a little bit of pressure. And you can see here that the top of the bridge part on the lock is actually curved to exactly align with the profile of the enclosure here, like that. That's how you know it's all the way in and that it's in the right way, because it's perfectly flush with the enclosure. And then on the inside, it fills in the gap perfectly. So you can see in here, the gap between the socket and the wall is completely filled in. So it's pretty well locked down. The bridge holds it down vertically, and then left to right, it's not going anywhere. So yeah, now we're ready to do the heat set inserts. We're going to use M3 inserts because M3 screws are just really strong. They're going to fit nicely into a small area, but they also provide a lot of strength. And so we're going to do 2 inserts into the socket. I'm going to get them started with my hand so they kind of stick in there. And then we're going to carefully do this part without burning myself on camera. So let's see if we can get this done. The alignment on this is tricky. You have to make sure it aligns flush and to the curvature of the enclosure. So that's that. And then we're going to do the second one here. That's that. That looks pretty good. Let's take a look. A little bit of squeeze out, but not bad. Pretty clean overall, I would say, on the front and the back. Yeah, that looks pretty good. I like that. And you'll notice on the front side of the socket right here, or actually towards the back, there is a little raised area, like a little lip right there. The reason why that's there is because on the ear cup itself, so this is the finished socket right here. We're ready to install this bad boy, but on the ear cup itself, there's actually an alignment recess on the side of the cup, and you can see it right there. So you see that little recess in the cup on the side? So the lip on the socket actually aligns with that perfectly. And that helps us with installing the socket perfectly centered so that it's not crooked when it goes in. You know, I have OCD, so like when I put these sockets on, they have to be perfectly straight. Like, you don't want the socket to be, you know, misaligned in any way up and down. So like, you know, like you don't want it to be like, you know, too forward or too back. It has to be the perfect alignment here. And then as far as side to side, we're going to take care of that alignment when we start to put in the screws. And so you can see on the inside of the cup, those 2 heat set inserts that we installed, you can see them right through the ear cup. And that's where the 2 M3 screws go to secure the socket. So pretty cool. Once those 2 screws are in there, this is a very solid connection. It's not going to break. It's very, very strong. But the other cool thing is it's serviceable. So if for whatever reason something does happen to the socket, or maybe you want to upgrade the socket, I don't know, who knows, but like we can easily remove it just by undoing these 2 M3 screws and just unsoldering this from the driver and pulling it out. So we can actually fully service this part. It's modular, it's replaceable, which is kind of cool. The other thing is that if you refer back to the socket in the front here, the lock really does keep the socket in place, especially when it's up against the ear cup. This is just not going to move anywhere. But the other thing that's really cool is this front screw, when it goes down into the socket, it applies downward pressure onto the socket itself. There's a clearance, like all the way through. You can actually see the socket through this hole. And so as the socket moves towards the ear cup when it gets screwed in, you're also applying downward pressure to the socket itself so that it doesn't wiggle. I mean, the worst thing that happens is when you get a headphone where when you plug in the headphone cable, there's a little bit of play in the socket. You know, there's like a little wiggle, and over time that can actually get worse as you swap cables or just use a headphone. And so I wanted to make sure that this socket was super reliable, super sturdy, has 0 play, and will hold up to years of abuse. It's made out of really good, strong plastics and materials, and yeah, I'm very confident that this socket will have no issues for years to come. So yeah, that's how we build a headphone socket for the Dahlia, and I'm just going to add it to my little pile right here, and there we go. So thanks for watching this video, following along on how we build a socket for the Dahlia. I'll definitely be posting more videos on just yeah, just things I'm working on in the garage, building for all the pre-orders and all the headphones that we're going to be building here. And I hope you enjoyed it. Stay tuned for more on the HFA build series. And I hope you guys have a wonderful weekend. Take care.